Hey guys, today we're talking about dilations, and we're just going to run through these notes really quick so you can get to your homework. Let's start with the definition of a dilation. A dilation is a type of transformation that either reduces or enlarges a figure. With this, it means it can grow or shrink, but the shape doesn't change or the orientation. So up here, if this is our original image, from these choices, the only one that does not have a change in orientation or shape is A. The rest of these are reflections or like where the orientation changes. For these next images, we have what we call a pre-image and our dilated image. So with this, our dilated image got smaller, so we call this a reduction. With this, we're going to call this the old versus the new. This can always be also be notated as P and P prime. This is an example of an image being enlarged. So this is our old versus our new, or P and P prime. So the dilation uses what we call a scale factor to reduce or enlarge. If our scale factor K is greater than 1, then the image will be will be enlarged. If K is a fraction, something between 0 and 1, then the image will be reduced. If K equals 1, then the image will be the same. No change. So the next thing we need to do is talk about how we find the scale factor to determine exactly how much an image has been either enlarged or reduced. So the scale factor is a ratio. And remember last time we talked about ratio, where that's just a comparison between two quantities. With this, the way you set the ratio up, you have to do the new value divided by the old. We can also call that P prime over P, or image over pre-image. So just an example of that, with these two images here, we want to find what the scale factor is. So to know which one is the old and which one is the new, we want to look at the vertex, or excuse me, the vertices, and see if there's a prime or not. So do you see how this is just plain old A, B, C, and this is A prime, B prime, C prime. So this is the old and this is the new. So when we're trying to determine the scale factor, we're going to take and form ratios with corresponding side lengths and see what they reduce to. So I'm going to do new, which is 12, over old, which is 4. That simplifies to 3. Let's check the next. We have to check all three sides to make sure that it actually is a dilation. So we'll do new 16.5 over old 5.5, which is also 3. And then finally 15 over 5. So since all of these ratios simplify to 3, that means that our scale factor equals 3. And since this is bigger than 1, we have an enlargement. Okay, next page. So with these examples, we want to identify whether each image is a reduction or an enlargement, and then find the scale factor. So for this, notice that we have P and P prime. So remember, P prime is the new and P is the old. So when you look at this, we can see that we have like a bigger image for P and a smaller image for P prime. So this would be a reduction. And we can verify that by finding the scale factor. So remember, our scale factor is going to be new over old. So the new is P prime, which is the smaller shape. So it's 5. And then the original is P with a length of 10, which reduces to 1/2. And since this is a number between 0 and 1, we know we have a reduction. Second example, make sure you look for the P versus the P prime. So this is P, it's our old, P prime is the new. So you can see P is smaller than P prime, so this is an enlargement. And to prove that, we're going to find our scale factor. So remember, it's really important when you find the scale factor that you always do new over old, or P prime over P. So the new, the length for P prime is 20 over the length for P is 8. And 20 over 8 reduces to 5/2. So be really careful with this. Just because it's a fraction doesn't mean that it's automatically a reduction, because 5 divided by 2 is going to be 2.5, which is bigger than 1. So that proves that this is an enlargement. All right, so when you are talking about scale factor, you can express this in 3 different ways. You can write it as a fraction, as a decimal, or as a percentage. So an example as it being a fraction would be 1/2 or 1/4. As a decimal, it could be 0.5, 0.25, or a percentage would be 50% or 25%. So with the next set of examples, we're going to identify the scale factor and then use it to find the measure of the missing sides. So we're doing what we did before, finding the scale factor, and then to get, we're going to use that to find these missing side lengths. So again, make sure you identify which one is old and which one is new. So P is old, P prime is new. So you can see it goes from smaller to bigger. So we know that our scale factor should be something greater than 1. So to find the scale factor, we do new over old. So the new, we only know this length for the new image. So that's 12.5. You have to make sure that you pick the same, like the corresponding side length for the old. So that would be 5. And then 12.5 divided by 5 is 2.5, which is greater than 1. So we know we have an enlargement. So to get our side lengths, that means that we have taken the pre-image and multiplied each side length by this scale factor. So to get X, that's going to equal, this length corresponds to 8 in the pre-image. So that will be 8 times by 2.5, which is 20. And Y, that's this length, corresponds to 4 in the pre-image. So that's 4 times 2.5, which is 10. Okay, let's do another example. So first identify your pre-image and your image. So that's the old and the new. So P is the old, P prime is the new. So here we can see that we have a P is going to be, is this an enlargement? No, we have another enlargement. So the side links that we know 12 and 4. So we're going to find our scale factor, which is new over old. New would be 12 over old is 4. So we have a scale factor of 3, which is bigger than 1. So we have another enlargement. So we're going to multiply the side lengths of the pre-image by the scale factor to get the new side lengths. So we have x equals, x corresponds to this side length in the pre-image. So we have 5 times the scale factor of 3, which is 15. And y corresponds to 6 in our pre-image. So we have 6 times our scale factor of 3, which is 18. Okay, next page. All right, so now we are going to talk about dilations on the coordinate grid. So we're looking at some images where we're given the points of the image. Again, you have to really be careful to make sure you know which one is the old and which one is the new. So the way you know that it's new is it will have the little prime, the little kind of tick mark up there. So let's look at our coordinates for each point of the original. So the original A is the point 1, negative 2. B is the point 4, negative 1. C is the point 2, negative 3. And then A prime's coordinates are 2, negative 4. B prime's coordinates are 8, negative 2. And C prime's coordinates are 4, negative 6. So to see our scale factor, again, we always do new over old. So let's start with A. Negative 4 divided by negative 2 is 2. And you could do this with any of the coordinates. 2 divided by 1 is 2. Negative 2 divided by negative 1 is 2. 8 divided by 4 is 2, and so on. So our scale factor is equal to 2, which means that this new image is an enlargement. All right, next we want to take our pre-image and use the given scale factor to draw the dilation. With this, we're using the center of the dilation to be the origin. So we're going from 0, 0. So first, we need to find our coordinates for the 3 points on this triangle. And then to each of those coordinates, we'll apply the scale factor. So we have V, U, and R. So V, U, and R. So the coordinates for point V are 2, 3. Coordinates for U would be negative 2, negative 1. And the coordinates for R will be 5, 0. So we're going to multiply each coordinate by our scale factor. So we're just multiplying everything by 1.5. And you can just do this on your calculator. So V prime, 2 times 1.5 is 3. And 3 times 1.5 is 4.5. U prime is -2 times 1.5 is -3. And -1 times 1.5 is -1.5. And finally, R prime is 5 times 1.5 is 7.5. And 0 times 1.5 is 0. Once you get the ordered pairs for the new image, you're just going to plot those. So V prime would be at 1, 2, 3, and up 4.5. 1, 2, 3, 4, and a little bit. And then -3 and -1.5, and 7.5 and 0. And then just do your best to connect the ordered pairs to get your image. That's not very gorgeous, but it's okay. All right, let's do the next one. So we have a scale factor of 50%, which we could write as k equals 1/2. So we know we're going to have a reduction. And again, you can go through and find all of your ordered pairs, multiply the x and y's by 1/2, and get your new coordinates and plot those. So what I want you guys to do now is work as a class. You can work with your partner to do this classwork and see if you can get through this. And when you finish that, go ahead and get your homework out in your packets and get that done. See you guys later this week. Have a good day.